Okay, here is our review for our unit test number 1. The first thing we're being asked to do is classify the given numbers. -7 is an integer and a rational and a real number. Remember, it's rational because it can be over 1, which means it can be a fraction. Therefore, it's rational. Remember that natural numbers are 1, 2, 3, and so on. Whole numbers are 0, 1, 2, 3. Integers are all of those plus the negative version of the whole numbers, -1, -2, -3. Rational numbers are anything that can be a fraction. And irrationals can't be fractions. And real numbers are all of the rational and irrational. So 3/4, not natural, not a whole number, not an integer, but it is a fraction, so it's rational and real. This number is 0.9 repeating. That's one of the kind of decimals that can be a fraction. So that's rational and also real. 5 is a natural number, a whole number, an integer, rational, and real. And 0.398, because it's a decimal that ends, that means it can be a fraction. It's rational and real. So let's do a little talking about decimals real fast, because I've been getting a lot of questions. There's, I think, 3 different kinds of decimals that we talked about. We talked about decimals that end, like 0.25, for example. That can be a fraction, therefore it's rational. We talked about decimals, 2 different kinds of decimals that never end. One where the decimal is repeating. That can be a fraction, like if you have 0.3 repeating, it equals a third. That's going to be rational and real. And then we had decimals that never end and never repeat. So like pi or a non-perfect square root. So pi is approximately 3.14159. That decimal will go on forever and it won't repeat. Same thing with a non-perfect square root, like square root of 2. There's no pattern and it never ends. When that happens, we call those irrational. So rational decimals either end or they never end, but they repeat. We would call those rational. And if it's a decimal that never ends and never repeats, we'd call those irrationals, and they would all be real numbers. So then ordering numbers, remember 9/4, we're going to convert to a decimal. So we'll do a little division here. So that is 2.25. Square root of 10 is a perfect square root rather, so that's 10, and then we just put everything in order, least to greatest. And when you write your final answer, please use the original form of the numbers. I'm going to list them with squigglies. You don't really have to do that. I just felt like it right now. And then the true-false statements, every integer is a real number. So you see how the integers here is to the left of the real numbers? So everything that comes before this last column is included in this column. So if integer is farthest to the left, it means it's included in the real numbers, and it's also included in the rationals after it. And remember that a number can never be both rational and irrational. So it has to be one or the other. So if the check mark is in front, it's also included in the categories behind it. So every integer is a real, that is true. All real numbers are whole numbers. Well, here's the category of real numbers. Not all of these are going to belong to what comes before it. So whole numbers is before. So it's not true that all real numbers are whole numbers. For example, 3/4 is a real number, but not a whole number. So this is false. No irrational numbers are also real. Definitely false. All irrational numbers are also real. Every integer is also a rational. That is true. Every integer is also rational. You can take all the integers and put them over 1, and then they'd be a fraction, and therefore they are rational. So that is true. All whole numbers are integers. That's true. All whole numbers are integers also. But not all integers are whole numbers. That's true. I misspoke. 0 and all the negative natural numbers are not whole numbers. So that is true. Okay, these next two problems are practicing order of operations. Remember that when we have P for parentheses, it means for parentheses where there's math inside. So here's the difference. This first set of parentheses has math inside that I can perform. These parentheses have just numbers inside, so I don't really have to focus on those for this first step. There's nothing to simplify inside. These parentheses are just indicating that these are being multiplied together. These parentheses have something inside that I can do the operation, so I'm going to start there. So 5 minus 7 is a -2. I'm going to write that down, and everything else I'm just going to bring down exactly how it is. So then the next step is exponents. There are none. The next step is multiplication division. There are two multiplications, this one and this one, and I'm going to do them left to right. So I'm going to do half of 2 is 1, and a negative times a negative is positive. So +1. Then I'm going to write down my minus, and then I'm going to do 2 times -6, my next multiplication. That is -12. Minus a negative is a plus, and now I have an addition. 1 plus 12 is 13. For this next problem, we're going to start by plugging in 2 and -3 for my x and y. This negative in the front, I'm going to leave and not do anything with that till the very end. Remember, when you have a fraction, you want to use the order of operations all the way in the numerator till you can't anymore, and all the way in the denominator until you can't anymore. And then at the end of all that, you're going to simplify if possible. Now, in this problem, there's nothing left to do in the denominator because it's just 8. But in the numerator, here's what I want you to not do. This is a bad math alert. Do not do 2 minus 7 first, right? Multiplications come before add or subtract. So I have two multiplications. I have 7 times 2, and then I have kind of a 2 times -3. So since you might be wondering, well, which one do I do first? And we want to practice doing them from left to right. So that means I'm doing 7 times 2 first. I'm not going to include the negative. So negative, okay, here's my 2 minus 7 times 2 is 14, and I still have the times -3. So now I'm going to do this multiplication and leave everything else the same. 2 minus 14 times -3 is a -42. Now I have minus negative makes a plus. So that's +44 over 8. Both of these numbers have a 4 in common, and the negative is just going to stay out front. So -11 over 2. Now I want you to pause your video and try the back all by yourself if you don't already have it done. I'm not going to teach them step by step. I'm just going to talk about the answers from the key. So take a minute, Try those if you haven't. Pause your video and then come back in a moment. All right, in this first section, so on the quiz, a lot of people got the additive or multiplicative part correctly, right? If it's adding, it's going to be additive. If it's multiplying, it's going to be multiplicative. Unless it's distributive. The very last one is distributive. It has a multiply and an add. So we're distributing the A here, so A times B, plus distribute the A there, A times C. But how do you know if it's inverse or identity? So inverse is going to mean you're taking the opposites of something. And identity is going to mean something is identical. So in these first two that are inverse, you'll see that we're adding two numbers that are opposites of each other. So we're adding the opposites, the additive inverse. When multiplying, the opposites mean reciprocals. So 1/7 is the reciprocal of 7. So here we're multiplying the opposites, so multiplicative inverse. These two are identities because you're ending up with the exact identical thing that you started with. So adding 0 gives you the same thing you started with. Multiplying by 1 gives you the same thing that you started with. So that's multiplicative identity and additive identity. On number 7, for associative property, that means you are changing what is being grouped together. So originally 3 and 4 was grouped together, and then the way I wrote it, 2 and 3 was grouped together. And commutative means you're changing the order. So we're multiplying 2 times 3, but if we change the order and do 3 times 2, we're going to have the same answer. On number 8, on number 7, we were told the property to use. And on number 8, we are choosing the property and showing how we're using the property to rewrite this in something that's true. It's going to give us the same answer as the original. Now, we're not actually doing the math, we're just rewriting it. So I chose to show distributive property, right? Because if I distribute 3 to the 5 and multiply, and then 3 to the 7 and multiply and add them, that's distributive. And then I showed commutative property of multiplication, because I have 3 times this group 5 plus 7. I just switched the order. Now I have the group first times the 3 second. So that is commutative of multiplication. You could also do commutative of addition by switching the order of the two numbers inside the parentheses, right? Because 5 plus 7 and 7 plus 5 are going to give you the same thing. Number 9 is just mental math. The square root of 25 is 15. And number 10, square root of 98, I start by dividing by 2, which gives me 49, which is 7 times 7. So for each pair, I pull out 1, move it to the front. I have 7 square roots of 2. You also could have done like this, stopped at the perfect square of 49, simplified to 7, and brought it out front and still have 7 square roots of 2.